Understanding the simple concept of signal flow will benefit your ability to mix because it will allow you to move from one DAW or physical mix console to another because the underlying mix principles are the same. You'll also find that troubleshooting is easier when you understand signal flow. You'll also have a better understanding of the different ways in which you can accomplish the same result. Signal flow is basically just following how the audio flows through a signal chain from the source to the destination. For example, if you're recording a vocalist, the signal comes in through the microphone, travels through the microphone cable, through a preamp, and maybe even a compressor, then hits an audio to digital converter if you're recording digitally, and is then recorded to a hard disk as ones and zeros. If you're recording to an analog device, such as tape machine, your signal will be recorded to tape instead of being converted to a digital signal and recorded to a hard disk. An easy analog to think of how signal flow works is to imagine a river coming from a lake. The lake is the source, which could be an audio file or a tape machine. And the river can flow through things like dams or over waterfalls, which will be like the plugins and the inserts. The river can even split into two different streams and end up at multiple destinations. With mixing, we're starting with material that's already been recorded. When working with Logic Pro, our source will be the ones and zeros in each digital audio file that's stored on our hard disk. These audio files are read from the hard disk by Logic and then play from each track in Logic through each channel's virtual bus, through any inserts or plugins along the way, and arrive eventually at the master bus, where the signal is combined with all the other source signals to create our mix. That final mix signal is then printed or bounced to disk as a new audio file that stores these new ones and zeros. Our signal can even be split and routed to multiple different destinations, just like the river in our analogy. With panning, imagine that a single stream of water is bifurcated into two streams. These two streams could represent our stereo mix bus. If the panning is set to center, the same amount of water or signal goes down both streams. If the signal is panned more to one side or the other, more water or signal goes to that side and less to the other side. When we change the level on a channel, it's like letting more water pass downstream. If we lower the level on the channel, it's like letting less water pass downstream. When we mute a channel in Logic, the signal flowing through it is stopped and is no longer being sent out to the channel into the mix bus. And when we solo a channel or multiple channels in Logic, only that channel or those channels are sent to the mix bus. Another concept that relates to mixing is gain staging. Gain staging is simply the idea that multiple stages in your signal flow can alter the gain of your signal. For example, if you're mixing a signal through a channel strip and using the volume slider, that's a gain stage. An EQ would be another gain stage, and a compressor yet another. It's important to keep this in mind while mixing so that you can keep the gain at a reasonable level at each gain stage, and so that you can use the gain stages to raise or lower the level of the signal if needed. The goal is to keep your signal sounding clean without being so loud that it clips or so soft that it's too quiet to hear without cranking your speakers. Changing the inputs and outputs of a channel will obviously affect the signal flow as well. You can use inputs and outputs for various purposes like setting up an effects return or sending multiple channels into a submix